Yo, what's up, what's up, what's up? Welcome back. Today we are working on my QR code decoder, and we're on day 2. And the goal is to try to extract pixels, I'm going to call them. I don't know what the correct word is, but like individual pieces of data from the QR code. So what we have so far is yesterday we kind of started by getting some... Getting some QR code. Let's open up our example. This guy. So we have a QR code. And what we have is this like executable that we can run that takes in the QR code and outputs like some SVG file. And that SVG file is essentially like our internal visual representation of what we've done to it. And so if we look at that guy, we see that we have like green dots in the 3 corners of the QR code, which is indicating that we've done some form of extraction of the QR code from this guy, right? So if I like try to highlight where the image ends, it's not the corners of the QR code. Well, I guess it kind of is, because the QR code spec, well, I haven't read the spec because it costs money and I'm not going to pay $200 to read this, but the Wikipedia page says that there should be some like border around it. So I guess like technically it's part of the QR code, but like where the data is not here. It's kind of like here, right? Where the borders of like the boxes end. So we've like found the 3 corners. The way we did it is like pretty rudimentary. We just kind of like do one-dimensional scan lines and try to look for the pattern of like 1 1 3 1 1, right? So black, we're looking for like a segment that has 3 times as long in the middle in the border, and then we do that in both X and Y and find where they intersect. So right, if we can, I think that I can just like go in here and I can just delete elements from this visualization in the browser. Hell yeah. So the red dots are where we found that pattern horizontally, blue dots vertically, and then we find the intersection and draw a dot there. Great. So this is only going to work in very nice cases for us, but that's okay. That's all we have to worry about for now. Later, we can worry about like what happens if it's like rotated a little bit, but for now, we're not going to worry about it. So from here, the thought is, since we know where these guys are, we should be able to figure out where the corners of them are. And we should be able to use that to extract information about where the border of the whole QR code is. And then from there, we should be able to kind of iterate throughout this thing and extract whatever these like blacks and whites are. We should be able to like take those out and turn them into something that we can work with. So that's the plan for today. That's the plan. So I think the rough plan of action is to like extract this like region of interest. I want to double check these like timing patterns. So here, there's like 1, 2, like alternating colors along these 2 this like row and column. So maybe we start there. That'll let us like prove that we have like iteration of some form working. We can like build up a visualization at that point as well. And then we can work on like, now let's do like the actual walking of data the way that the QR code spec says we should. That's the plan. That's the plan. Okay. So let's get moving. Okay, so what are we doing here? We have this QR code module, and he says, hey, I'd like to find the finder patterns. And right now, all he does is he just draws the visualizer. He doesn't return anything. So that's the first thing we're going to have to fix. We're going to have to like return where these guys are. And maybe we want to return not just like their centers, like we are here, but maybe we want to return like a square representing where they are in the image. Is that what we want to do? Let me think about that. I think that is what we want. Well, I guess we could also say center and width and height, which is essentially, that is exactly the same thing. Okay, so let's do that. Let's call this a rectangle. And in this language, we write const rect is equal to a struct. And he's going to have center position as a float, a center x, center y, a width, and a height. Like for our purposes for now, you could kind of assume that these are square, but I'm thinking forward a little bit to as we start dealing with slightly deformed things, like they're rotated or they are squished in some way, it would be nice to just keep them separate. So we'll return some rects. So this guy, he should return array list of rectangles. Okay. So what do? We find the we like run length encode these guys. So we say, hey, for each line you're gonna go over, tell me like give me 1 1 3 1 1 1 3 1 1, right? Like so like how many of the same color we see in a row. That's like the format here. And this guy tells us where he starts and the length of the run. Okay. We take those and we construct some like candidates for centers of the finder pattern. And here we're only storing its XY position. And so now we have to kind of store some more info here. We also need to store its like length in pixels. And so this shouldn't really be called a point anymore. This should probably be called like a finder candidate. I don't know. Doesn't really matter. Doesn't really matter. And here we're just going to let's see. Here he has finder candidates. He returns array list of usize. So this is where within a scan line that he is, i.e. like in one dimension, he's going to give me this pixel, or he's like, if I'm like iterating left to right, he's going to give me these red dots here are the position in X at this row. So there's, we want to return the like size, the potential size of him as well. So maybe here we'll say finder candidate is going to be we'll call this like finder candidate 1D because we're working in one dimension here. And we'll call this position and length. I like that. Here he's going to return a finder candidate 1D, a bunch of them. And all we need to do here is when we append the candidate position, we'll say const center, and maybe we should call this center instead of pause. I think that'll be clearer. This is just going to be whatever we were doing before, which is pretty unclear. Okay, so there's like kind of like 5 segments here, right? 1, 2, 3, 4, 5. Let's go back to the original QR code. Black, oh god, zoom in. Black, white, black, white, black. And so we're kind of saying this is like index 0, 1, 2, 3, and 4. So here if we want the total length, the total width, we should just say length is equal to RLE 0 length plus RLE 1 length. But in reality, like, we could add them all up, but we kind of know that it should be the reference, like the first value, ref.length times 1, 2, 3, 4, 5, 6, 7. That's what we should expect. I've been following on YouTube. How are things today? Hey, welcome. Things are good. Things are good. And so now we can say the center is the center, and the length is the length. And really, we don't need to do these calculations out of line. We can just do them right here. I don't think that's any less clear. Okay. Okay, so now this guy is returning he's returning both the center and the length. And we can use that here to say that the finder candidate 2D, let's call this finder candidate 2D, his length is going to be just the length that we got back. Something about this feels wrong. because here we have like width. We should have like width and height. So maybe we make these. We just use like these are just the rectangles, I guess. So we don't need this Finder candidate 2D. And what we'll do is for the vertical candidates, we'll store height, and width will be undefined. Yeah. Okay, that seems good to me. Let's just make sure. So here we're iterating a column. So that is height. Yeah, okay. Then on the width side, we have to specify height as undefined, and width is equal to candidate length here. And this should be candidate.center. Okay. So now we don't want to check that the whole candidate is equal because the width and height now are going to vary. So we only want to check if their centers are equal. So we can just split out a little center. Maybe we'll do an external function. Rect centers equal. Sure. Yeah, and we have rect1, A, which is a const rect pointer, and B, which is a const rect pointer, and we'll return a boolean. Yep. And then we just do a.cx. And is there like a standard library function for is close? It would be nice if there was. It's easy to write one. But you know, if it exists, we should use that. Zig standard library. Just seems like the kind of thing that would be in there already. Like in math, F16 epsilon, search for approx. Thank you. Approx equal rel, approx equal abs. So I guess rel probably is relative to the magnitude of the float. Oopsies. Approx, it's this one. Performs an approximate comparison of two floating point values, x and y. Returns true if the absolute difference is less than equal to then x absolute value, the bigger one times the tolerance. Yeah, okay. I guess probably defaulting to rel is probably the one you want, right? Like, because floats get less precise as they get farther from zero. So I guess it totally depends on your use case. But this seems like a better default to me. A good value for this parameter is usually square root float epsilon t, meaning that the two numbers are considered equal if at least half the digits are equal. Whoa, 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 what's going on here? Float eps t. So what is this? Returns a machine epsilon of floating point type t. And this returns... Oh, I see. So, doesn't the... What is the... Hold on. Oh, this doesn't make sense to me. This doesn't make sense to me. I want to look. So let's just comment out everything here. And just std debug print. Float epsilon is some value, and then we say std math float eps after 2. Like, what is this thing? And then comment this up to 2, I guess. QR, he's mad because this doesn't compile right now, so we'll just kind of comment this out. And float epsilon is 1e negative 7. Okay, so this is like absolute value, but doesn't the float epsilon change depending on your order of magnitude? Right, like float IEEE float. Right, like we have exponent mantissa where you take 2 to the exponent plus mantissa or something? I can't remember. Finite numbers, blah, blah, blah. Representation encoding memory. For instance, B is equal to 1, 0, 10, and p is equal to 7. I just want, like, the quick math. Mantissa. Is that how you spell it? Mantissa float. Am I crazy? Oh, yeah, here we go. Here we go. Yeah, so it is just like Mantissa. Symbol final value is b to the exponent times s over, where s is the sign, so it doesn't fucking matter. Use precision. Okay. Yeah, I guess I was under the impression that it's like there's not one absolute value that can be used at any range. So I guess this must just be the assuming that the power is 0. Sure. And so they're saying a good default value is when you're kind of near 0, like half your decimals are in space, I guess. Which I guess is like fine. I mean, I'm okay with that, but it's just like a confusing, like not confusing recommendation. I think it's a fine recommendation. It's like just confusing wording to me. Okay, sure, whatever. It doesn't really matter. Okay, so stood, math, float. What is it? Approx equal rel. Is this, and I guess this will be computed at compile time, which is kind of cool. Note for comparisons of small numbers around 0, this function won't give meaningful results. Whoa, 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 why? Why? I don't understand what the difference would be. I guess if it's like really close to 0 and the sign might flip. Performs approximate. Okay, wait, can we just look at the fucking source? Approx equal abs. So I would assume that this is just like, yeah, abs x minus y is less than tolerance. Abs x minus y is less than tolerance. Oh, but maybe multiplying. Oh, I see. Because if you were to take the max of these two really, really fucking small numbers and multiply them by the tolerance, it might just floor to 0. Because like you can't, if your tolerance is like a multiplier on a very small number, you won't get a accurate smaller number. Okay, sure. I'll just do what I would normally do, which is I would say approx equal abs, and specify like, I don't know, 1e negative 4 or something. It doesn't fucking matter. I guess we expect these to be in pixels, so maybe even like 1e negative 2. We don't really care if they're like super, super close. 4's fine. 4's fine. Okay. So we return that this is near equal and this is near equal with the center y. And here we can say tolerance. What's the, there's no, people don't like uppercase everything in this language. I think they just say tolerance like this. Like this, boom. And do I say this? I probably don't have to specify the type, and then we can write tolerance like this. Fine. Okay. So here now we say we want to say it rect centers equal for the vertical candidate and the horizontal candidate, and then we push our response back. So we need to specify a return value. So we say var ret is equal to stood array list rect with an allocator initialized. We need to free that thing if we fail. So we say error defer ret dinit. If we don't fail, then we're fine because we want the caller to free it. So we don't worry about it. Down here we return ret, and here now we can just say ret dot append. We have to try that, and here we have to do some clever merging of the two candidates because they're going to have undefined memory in some of them. So here we want to say cx is equal to, doesn't matter. Same with the center y. The center y and the center x are fine. But the width and height, we have to be careful about which one we take from. So height is undefined for horizontal. So here we take this from vert candidate. Boom. And this should be width and height. Cool. Okay. I'll just say note undefined width height for vert horiz candidates. Okay. Okay, so then the caller of this guy has to free it. So find finder patterns. It's probably main. He's unused, so that's why find references didn't find him. Because I comment him out, and we could say finder patterns is equal to this, and defer finder patterns.dnit. Cool. So hopefully everything works, but it does not. Something is an error union. Wait, okay, it expected an error union, and it found an array list of view sizes. That's up here. Finder candidate 1D. Could we replace the maze with the ASCII art generator output? Like, you want to run it, do you want to run the ASCII art generator on the maze itself? Because otherwise, like, it needs some input. I assume that's what you mean? In which case, that's not a bad idea, but will I do it? Probably not. usize does not support field access, so why does... Oh, oops, I see. That or looping against random images. But maybe you're right, though. It does seem like we should, like, eventually it will be boring. Fair enough, it's work, I get it. Yeah. Okay, CX, CY, these should be CX and CY like this. Expected type F32 found usize, that makes sense. So here we need to say float from int. And I guess technically these should be adjusted by 0.5. Does this fix it? No, this guy needs to know his type as F32. Because pixel 0, 0, like the top left corner, the center of that pixel is actually 0.5, 0.5. So here we want to actually adjust these to their center of pixel. And I guess that's the same here. So this is going to be as F32, float from int plus 0.5 as F32, float from int plus 0.5. Okay. Length, again, he expects float. There's an argument here that I shouldn't be working in floats here, and I should be working in pixels. But my gut says that later I'm going to want this in floating point, but maybe not. But what you gonna do? Think? Plan? Do the right thing? No, we're just gonna blindly type shit. And then figure it out later. This is float from int. This, and this should also be float from int. Okay, are we chilling now? We're close. Expected integer type found QR finder 1D. Okay, so that's at 84. So here when we're drawing the circle, we need to draw... What is my visualizer API here? Draw a circle. He has CX, CY, radius. So... candidate dot center float from int y. Yep, that's fine. We have to do that for the blue one as well. So this is a... Oh, no, that's fine. What does x come from? X, y. So this is float from int candidate dot center. Yep. And then down here, we need to write in maybe we store this guy. So we'll say full candidate is equal to this shit. And then we try ret.append full candidate. And then we can use here directly full candidate.cx full candidate.cy. I guess we didn't even need to do that. We didn't do that. Undo, 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 undo. We can just use vert candidate.cx and vert candidate.cy. Perfect. Okay. So at 113, we forgot to put little ampersands on these guys to make the pointers. And then this guy expected 4 arguments, found 3, because I forgot to put the type here. So he needs to know if he wants to be looking at 32-bit floats or 64-bit floats, I guess. Okay, we're chilling. And so far, nothing should have changed. It does look like this green blob now is kind of in the wrong position. Maybe that center offset was actually kind of wrong, which is surprising to me. Quite surprising, actually. It does look a bit off center, yeah. I would have thought that the center should be halfway into pixel, but I guess there's a possibility that, can we open this thing in, like, color paint? I just want to look at, like, the grid itself. So, how many pixels tall is this thing? Where's my pencil? One of these is a pencil. Pen? No, I want pencil. Pencil, here we go. And give me, like, the smallest fucking dot you can draw. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's probably... interesting. Can we maybe delete the circle for a second? And can I, like, zoom in farther? No. Yeah, it is 100 by 100, huh? So could be that the center calculation is wrong here. So in one dimension, our center is start plus length over 2. Maybe we like just quickly debug and look at this. GDB zig out QR decoder. I think you do like args here and then write input untitled.gif output test2.svg. Then we can break on this line here and run. And can we just like print this? Great. Print rle dot pointer rle plus pointer plus 2 dereference. There we go. So we have the start is at pixel 12. The length is 4. So that's going to give us averaging these two. Oh, this is, oh yeah, plus length over 2. So this is going to give us pixel 14. Which seems fine. Let's look at, whoa. Let's just do this a couple times. Yeah, it's giving us 14 over and over again. But I think in our thing here, we saw Oh, we have to finish this or else, Okay. So I'm not seeing 14 anywhere in this SVG. Right, I'm seeing 22 and 27. So where is this 14 going? Find our candidates. Because these guys should now be turning into 14.5. 14 or 41. I mean, I was seeing a start of 12, length of 4, which should put us at 12 plus length over 2. So that should put us at 14. So where is pixel 14 here? It's telling me pixel 14 is here. So that's just like fucking stupid. Yeah. So that 14 is just wrong. What am I thinking about here? I must be missing something obvious. I must be. I'm gonna log this instead. In case that I was like using the wrong unit in GDB, that seems possible. Center is this thing. I'm just not convinced. Oh yeah, okay. It's a bunch of 22s. So whatever the fuck I was doing in GDB was just wrong. Okay. 22. That might be something a little more sane. So we're going from 22 to 22.5. So that looks like... this is 0 indexed, so 22 is like here. And what do we think center should be? 1, 2, 3. Let's draw this. Oh, fuck. Just to give something to look at. So I think that center is... Ah. Yeah, so I think center is between 2 pixels. Which is probably the problem here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it's even. So it should be interesting. Interesting. Oh, okay. So the problem is we're doing the math as pixels that are dark, right? We have some range of like A to B. And then we're saying that the center is equal to like B minus A, kind of. But the problem is, the center is actually from the left edge of A to the right edge of B. So you actually have to add 1 before you do the division. And then these guys that comes out also have to be floats. Which means that this also has to be a float. Because we have to have like sub-pixel accuracy. So here we'll just note that length is encoding from the left edge of the first pixel to the left edge of the last pixel. Or I guess like you don't really know. Okay, length is in units of pixels. Note that if we want the center, we need to go from the left edge of the first pixel to the right edge of the last pixel. Therefore, we need to add 1 to the length. Yeah, I think that makes sense. So we can say var center is equal to this as f32 this plus as f32 sorry, this thing, not the divide by 2. The divide by 2 has to come after. Plus 1.0 divide by 2.0. Okay. There we go. And the length, I guess length we can convert first. So that's this. Oh no, yeah, that's fine. So this needs to be ref times 7. Ref times 7 plus 1. For the same thing. I think. I guess we'll find out. Now, there's probably some casts of these guys that I don't need to worry about anymore because now they're floats. I think probably float from int will fail now. Hopefully. Expected F32 found usize. Ah, fuck me. Float from int. I will say I like the explicit cast that, like, from a safety perspective. But dude, reading this, it's like, what the fuck am I looking at? Which I guess just means I need more temporary variables. So we'll call this, center, what do we want to call, what should I call, like, the block in the center of this, like, this guy? It's like 1, 2, 3, well, we'll call this, like, maybe finder center block. Center block. Center block length. And we will call this a float. And we can say that we have float from int of the length. Okay. Const center is equal to, I guess we'll call the center block start. Store that as an F32. And then we can do this as one piece. And then we can say var center is equal to center block start plus center block length over 2 plus 1. Yep. And then we have to say length here gets same treatment where size is same as above. We'll call it same as above. Adjust for left and right pixel edges. Okay. There we go. Maybe. So if we run this now, does the center look better? Fuck. Float float from it. Okay. Expected integer type found after 2, so this is 87. So now we don't have to do these int casts. They come for free. Which is the same as these ones. Oh, oops. These ones actually were needed. Fuck me. Some of them, because this x is still an int. Okay. And then it's the candidate lengths are now floats as well. There we go. Candidate from candidate center at 91. And this one too. All right, are we chilling? We're chilling. Refresh. Still seems to be pretty offset, huh? And huh. Okay, so what are we looking at now? Now we're looking at for the horizontal. Okay, hold on. Am I stupid? Sometimes. Okay. 22.5 for all of these on CY. So my head like hurts when I think about iterating horizontally means that we're finding the vertical center. Is so it hurts. Okay. Okay. Let's start. Let's just like reduce information here. Okay, only blue. Blue is still wrong. It's too far down. It's too far down because his Y value is 22.5. Where does the Y value come from? It's hard-coded. Right. So we're saying for each Y position, I'm going line by line. We're going line by line. Yes. Okay. And we are trying to, we get some run length encoded things, and we say, hey, did you find a candidate? And he said, I did find a candidate. And we say, great. Now, our X positions for these also don't really look right, by the way. It looks like they're kind of offset to the left. Oh, because we don't need to add 0.5 to candidate center. Weird that didn't have an effect, actually. Oh, because this is not the one being fucking written. Oh my god. Okay, sorry. This is we're iterating over image width. And we think that we are too far down, also too far to the left. Okay. Our candidate center plus 0.5. Oh, we don't need to do this candidate center plus 0.5 because the center is already adjusted for. So that's a bug. And so now and does our X value need to be plus 0.5? I think he does. I think this is right and this is wrong. Unless our finder candidates are referencing off by 1. What if I'm trying to think, like, how do I break this problem down further so that it's like more clear to me what's happening? We could maybe draw, instead of a circle, we could draw a rectangle, or we could just start printing stuff. We kind of have printed stuff by writing the values in here. Okay, let's see if we think CX can we? Okay. So our X values are even pixel values. Why are we iterating over, oh wait, we're iterating over X. Sorry. Brain farting. We are iterating over X and we're trying to find the center Y. So this is all we should be worried about right now is center Y. And we're saying center Y of 22.5. And we think that the center Y should be on a pixel boundary because we know that they're 12 by 12, right? That's what we found in color paint. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we think the center should be at 1, 2, 3, 4, 5, 6, like right here. Right at the beginning of pixel 22. I guess it depends on where the SVG renderer is drawing the center of the pixel. It's probably drawing the set. It's probably drawing in the center. Yeah. And we are considering this thing as the edge of the pixel, which is wrong. Okay. This is making sense. Dude, this gets me every fucking time. Every fucking time, man. Okay, so you have pixels 0, 1, 2, 3, 4, 5, right? Say you want to consider the center as this position here. Now you have to make sure that everybody is using their indexes relative to the same point in the pixel. And so I think what's happening is that SVG is saying that they are drawing in, like, the center of the pixel is the value. So if you say 0, you're drawing at position 0.5 in the image. I think. That's my guess right now. And we can probably prove that. If we were to make a shitty SVG, and we were just to say, hey, let's just fucking make a 1x1 thing and put a circle with radius 0.5 in the center of that 1 pixel. I think what we should see we actually can't zoom in enough, which is kind of funny. Can I, like, maybe open this with color paint? It's impossible to see here, but I'm pretty sure. No, I can't prove it. I can't prove it easily. Can I zoom in? Can I, like, set the Firefox zoom level to, like, fucking 1,000,000? Firefox max zoom level. Zoom more than 500. Firefox max zoom level. All right, I give up. But I'm pretty okay. Let's work with that assumption for now. I'm pretty sure that's what it is. Where SVGs are working in the center of the pixel. That kind of means that we should also work from the center of the pixel. Do I agree with that? No, I don't agree with that. I think that we should work from pixel top left. That's just what makes more sense to me, right? Because then if your width is 10 pixels, you can go from 0 to 10.99. I feel like that makes the most sense to me. Because otherwise, if your 0, 0 was like halfway into the pixel, then to get to like the top left corner of the image, you'd have to go to negative 0.5, negative 0.5. And I don't like that. I like 0 being the very top left. Okay, so that just means when we convert to SVG, maybe what we'll do is we'll handle that in our visualizer and just offset our CX by 0.5 here. And we'll just put a note here. SVG pixel center, or SVG is using the pixel center. And we want to be relative to the pixel top left. I think that's fine for now. I don't think that this is unreasonable, but it could be. I could just be doing something fucking stupid, but okay. That's a good sign. So I think that this thing is centered vertically. I agree with this, but it's not centered horizontally. So what up with that? It's that our x, we're iterating here from pixel 0 all the way across the right, and we're saying, hey, we found a vertical thing. And then this guy is saying, we found a candidate from this column. And why would he be off by 1, right? Like, this blue dot here is just feels fucking wrong. He's completely out of range. He's at 15.5. First of all, let's remove this 0.5 temporarily just to see. So he's going to get even farther to the left. And I wonder if it's possible that, like, this our SVG positions, are they, like, one index? There's no way. Let's just temporarily... Can I just draw something at, like, 0, 0? Or at, like, 0.5... 0.5. I just want to prove that if I do that, it should be in the very top left. So zig build and run, and we refresh. It's hard to see. Radius 0.5 as well, I guess. Dude, it's impossible to see that. Which makes this very difficult to figure out. Oi. Oi, 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 oi. Do I agree with this 0.5? I think I do. Okay. This is confusing to me. Like, it seems like this needs to be x plus 1. Whoa. Why did... Oh. No, that's doing nothing. Does it need to be x, like x plus 2? Am I fucking high? Is this... Why is this not changing? Should this not be... Oh, because it's down here. Oh, I'm just an idiot. Okay, I'm undoing a lot of stuff. Var cx is equal to this. Cx, I was just using the wrong fucking variable. And then this has to be cx when we draw, not offset. I bet you that this fixes it, but we'll see. It's not perfect. So if we were to add 1.0 here, it looks like kind of better, which is surprising to me. So that kind of like makes me think that this image column is coming from the wrong spot. Let's look at this column iterator again and just double check. So here we say, hey, give me this x position. So say we have... Okay, yeah, we take some width, some height, and some x position. And we get a vertical iterator. And he has an x position that he sets as his index. And then as he... Sorry, we should be looking at row. Row, not column. We are... Oh no, we're iterating column. Yeah, we're iterating column here. Right, because we're trying to... Each of these blue dots comes from a column iteration. Right, sorry. Fucking brain, dude. So he should... If he's 0, he starts at 0. And he's indexed by 0, so I see no problem with that. And so here, if we were like, hey... Okay, what if we were wrong here and SVGs are rendering relative to the top left? Would that change anything here? Maybe we just looked it up. SVG center position relative to our SVG floating point pixel positions. Surely someone just tells us the answer. Measured in pixels from the top left corner, with positive x being right. Defines a rectangle from the upper left corner that spans 100 pixels to the right. In the most basic case, 1 pixel maps to 1 pixel on the input device, but SVG shouldn't have scalable blah blah blah. Without further specification, 1 user unit equals 1 screen unit. Okay. The whole SVG canvas is 200 by 200. However, the viewbox defines a portion of that display, blah, blah, blah. 1 pixel corresponds to this much. Oh, I hate this shit. I hate it so much. SVG pixel top left. Has somebody like asked this before? Top left corner, because it's how CS is blah. In most cases, such a standalone SVG blah blah blah. Blah blah. The initial coordinate system, its own origin to the top left viewport. It's positive x. Ah. I hate it. I hate it all. There's so many places where I could be making like a very minor mistake here that like it's important to understand now. It's just like so important to get right. I just wish I could zoom more. Maybe if we open it with GIMP. But he turns the circle into something else. Okay. Actually, this is kind of giving us a clue, to be honest, where it's symmetric. I feel like there shouldn't ever... Oh, this because the circles are radius 1, which means that they bleed over the edge. So let's start with... Let's reduce the circle radius to 0.5 and just see if that gives me a better idea. So, Firefox about config, search for zoom manager, zoom values. I like that. Oh, so here I can just say like 50 at the end here and then get like really in there. It doesn't look like it. Doesn't look like it. Zoom manager. Allow zooming. Oh, max percent. Does that help? Oh, yeah, it does, baby. Okay. Okay. So this is definitely telling me... Let's go back to our 1 pixel test. And here, we can set the max zoom level to like 55,000 or something. Let's just get real fucking in there. Oh, hell yeah. Here we go. So, this is going to help us fucking understand the coordinate system. This is so sick. Thank you. Thank you. Okay. So, with center of x1, center y1, radius 0.5, it's picking the bottom right corner. So 0, 0 is picking the top left corner. So 0.5, 0.5 does exactly what I want. It shows the full circle. Okay, so that means our visualizer code here where we subtract this 0.5 is just fucking wrong. This should be exactly... Oh, no, wait. This is using... Yeah, SVG is top left. SVG is using top left. Is what that means. Okay. So now we should be thinking about everything we're doing as relative to the top left as well. which means that our pixel values here, I think I might still have like a plus 1.0 in here that I shouldn't. So if I want this centered in the center of the pixel, then adding 0.5 here makes a lot of sense. Yes, okay, those are all lining up, which is great, but their Y value, I think, is not. So if I look at this guy, I kind of want all of the Y's are, or all of the X values are 0.5 here. Oh, which is what I want. These are all of my X candidates. Ah, okay, and is their Y value here 22.5? I think that actually does make sense. We are... Yes. These are the centers of some pixels. And we had to pick... Hold on. X values, great. Happy with those. Y values, I'm actually not happy with them. The Y values, I think, should be... on a pixel boundary. So let's look at this again. Print, stood, debug, print, center, and we'll write it as a number, and we'll write the center here. And can we write the start and the length as well? And just see if anything in here looks wrong. Okay. Start, 16. Length, 12. Center, 22.5. So here, I feel like if we have 16 plus 12, we have 28. 16 plus 28 divided by 2, we should have 22. But then, because we're going to the bottom edge of the right pixel, then it should be... The plus one's wrong. The plus one's wrong. Okay, I was thinking. We have 0, 1, 2, 3, 4, 5. Here, if we want to go from the left edge of this to the right edge of this, that is how many? This is 1 to get to here, 2 to get to here, 3, 4. Oh, fuck. I need to draw it. So I have, this is 6 elements. And this is, looking at the left edge of the cursor, 1, 2, 3, 4, 5, 6. So the plus one's just fucking wrong. What? Let's try that. Let's try that. Yeah, that looks a lot better. Yep, that looks a lot better. Okay. Okay, so I think we got there. And now we just have to be very careful about adding in the other guys back. We have, this should be CY from Y. This guy gets CY. And here we draw CY. Here we can also draw him with a radius of 0.5, I guess. And these guys, horizontal count, CX and CY, still look great. Nothing in here to worry about, and maybe we'll do a radius of 2 here or something. And let's see how that looks. Now what's kind of interesting is these guys are perfectly centered, but now there's actually no position where the centers are equal, because my X values for the center of height are 0.5, and my Y values for the center of width are 0.5. So I actually have to be willing to take the, like, average of 2 or something. Right, I have to, like, say, hey, are my rect centers equal? but within some range. Which means that I wonder if there's a way to do this where we don't end up with multiple matches. Oh, that's kind of crazy. This is way harder than I thought it would be, actually. That's kind of fun. So what do we do here? We have to, like, look at individual points and say, okay, which points are close to you? If there are some close by at all, then that means that we're, like, near a center. And we almost want to do, like, clustering. We're probably, I bet whatever we end up doing, we're going to get 4 potential centers for each of these guys. And then we have to average them. Dude, that's crazy. That's fucked. Okay. So here we're actually going to make our tolerance 1. Which I think will make a lot of sense. Oh, raid coming in. Purple elf with the raid of 69. Nice. With a lot of people saying raid message. What's up, you guys? Welcome. For those of you just joining, what we are working on is we are working on the world's shittiest QR decoder. So we have some QR code. What we're trying to do is we're trying to figure out where the grid is. And so if you kind of like look at where the QR code actually ends, the image is ending not where like the corners of the grid are. And so we're trying to figure out, okay, how do we find the corners of the grid? Or how do we we want to draw a box around the QR code so that we can start iterating block by block, figure out like what each of these bits represents, and then do some actual processing with those things. But before we do that, we have to figure out where the corners are. And so we were kind of using this like mechanism of you can look for patterns in one dimension of 1, 1, 3, 1, 1, right? So that will find you kind of like lines where there are potential finders. And then what we were doing before was we were looking for the intersection of these like one-dimensional scan lines in X and Y, and where these guys cross, these red and blue lines, that's where like the center of these finders are. That was working okay. Except now we want to figure out, we want to go from the centers of these guys to our grid. And our centers are actually, in this particular image, the centers are not in the center of pixels. Which causes some problems here because now there's no actual point where these guys line up perfectly. We actually have like a cluster of 4 points lining up together. Like, I don't know if I can zoom in close enough here, but you can kind of see it here where like each of these circles represents one of our candidates. And here there's like, the red and blue never overlap with like one full circle over another full circle. So we were trying to like think through how the hell do we actually get the center, like one center point. And so here we were just getting to the point like, what if we allowed like 1 pixel error when we tried to find the centers? And so if we do that, I think that probably we'll end up with some green circles. Great. But the green circles are interesting that I'm not seeing as many of them as I thought we would. We are seeing 1. Oh, probably because we always use the horizontal. Yeah, when we draw the green circle, we're always using CX and CY from the vertical one. But I guess we could try averaging the two. So we could do, is there like stood, math, average? No, that's obviously not. So we'll say var CX is equal to vert candidate CX plus horizontal candidate CX, where CX is center. And we divide this by 2. And CY is the Y version of that. And then we'll draw that on the image. And let's just see what that looks like. Okay, so now we have 4 distinct circles, which is good. That's kind of more what I expected. And if we make them small, we can kind of see exactly where they end up. Right. And so now we need to go find some way to convert these 12 green circles into 3 points. And my gut... Okay, my first thought is k-means clustering, because I saw a video on that at some point recently, and it's like, oh, k-means clustering. But I think that you could do something else. We could group these by distance, right? We could say all of these guys that are within n pixels from each other, let's take the average of those. That seems reasonable to me. So first we say, hey, do this like fucking expensive n-squared search where we loop over all of our potential candidates and compare them all with each other. Great. Now, let's do it again. Let's do a little N4 algorithm. Fuck it. And let's just say, maybe we make buckets. Yeah, maybe we can get away with just adding some buckets now. So we'll say, var buckets. Yeah. Is equal to a stood array list of stood array lists of rectangles. I think that makes sense. Yes. Yes. Okay. Now, we have to, at the end of this block, destroy that memory. But actually, what we actually have to do at the end is we have to walk all buckets. We have to go like for buckets, bucket dinit. And this is buckets items. Okay. That frees the memory. Don't have to worry about that anymore. And I guess actually we know that we should have... Well, we expect to have 3 buckets, but I guess we don't really know how many there are. So I guess for each candidate, what we're going to do is we're going to say, hey, are our horizontal and vertical candidates close by some tolerance? Yeah, I like that. So we're saying, hey, are they like within 1 pixel of each other? If so, we're going to look through our buckets. Yeah. And we're going to look for if... Let's take like the average position of these guys before here. This. And then we'll just say if we're in within like 5 pixels, maybe we want to even do something that's like relative to the size of the image. But for now, we'll just say like 5 pixels. Fuck it. Blaze it, you know? Whatever. So we'll say var temp rect is equal to rect that's undefined, temp rect dot cx equals cx, temp rect dot cy is equal to cy, and then we can say fuck, I don't know, for bucket and buckets, this should be like a function. So we'll just make a function that's like add rect to bucket. Yep. And we'll take in our buckets, which is a stood array list rect. Yep. I guess I actually kind of want... let's make like a full proper rectangle of this. So we'll say our width is the average of the 2 widths, I guess. So here we're going to say width, and we'll do height as well. We make a full-on new rect, so var combined is equal to this thing, I guess. And then we can say, I guess we'll, yeah, add rect to bucket. That's it. Add rect to bucket. Yeah. And we take in the list of buckets as well as a rect to add. Yeah. Okay. And so here, this is where we do this iteration. So we say, this is combined here. Yeah. So this iteration, oh no, what happened? There we go. This iteration comes over here, and we say, hey, if we find a bucket that where we are close by, so we'll say that the for rect in bucket, or for bucket, I should say, if we find a rectangle that's close, so that's rect centers are nearby. Bucket, rect, and rect. And here our tolerance is going to be like 10. Fuck it. If we're within 10 pixels, then we add this to the bucket. Try bucket append rect. Yes. Okay. It's coming together. Otherwise, we need a new bucket. So, and so here we return. Otherwise, we need a new bucket. So buckets dot append std array list dot init out buckets alloc, I guess. Buckets here needs to be initialized with an allocator. Yup. And then we say buckets dot items. So this actually, both of this has to be dot items here. I forgot that this API is like kind of it makes like a vector that has an underlying slice, and you're supposed to work with the slice directly, and I always forget that. So buckets dot items items len -1. This guy is going to equal our rect. Perfect. And now we're going to have to like sort through our buckets. And so we're going to say for each bucket, we are going to average all of the rectangles in the buckets. So var cx equals 0, cy equals 0, width is equal 0, height is equal 0. All of these guys should be float 32s. And what we're going to do is we're going to say for bucket, we're going to have a rectangle. And for each of these guys, we're going to say cx plus equals rect.cx. And we're going to do this for cy, width, and height. And then at the end of this, we're just going to say ret.append cx equals cx over bucket.items len. This has to be commas, cy, width, and height. Okay. Maybe that fucking does it. And then at the very end, I guess let's make a new color for this, I guess. So we'll draw these candidates, these like merged ones, we'll draw them as green, and then I guess at the very end we'll draw something as like purple or something on top. So we'll say for ret.items rect, we just draw rect.cx, rect.cy, and I guess technically we should draw like a box around it, but for now we'll just draw a circle because I need to see something. Error is ignored. Try. Bucket.append, he doesn't like that. Why? Because found const array list, expected type array list. Did I write const anywhere? No? Oh, probably when I iterate, I have to iterate over a reference or something. I don't remember the syntax here for saying, like, do it by pointer, please. Yeah, there we go. Here I fucked up. This is rect. Need to make the generic type. No field named Alec in array list and lines. So he's storing it in the array list somewhere. I just need to figure out where. So I pull this guy out and it's allocator. Allocator. So pull the allocator out of the parent rect. Feed it to the child one. Or the parent array, I should say. Expected type this. Found that. Oh, this would be append rect, like this. Okay. And I misspelled items here a few times. Okay, fix that. And then incompatible types F32 new size. So I guess all of these averages have to be floats. So this bullshit. As F32 float from int. There we go. Please tell me we're there. Okay. And now at the very end, I wanted to draw these guys in purple. And please fucking tell me we got there. Boom! Let's go, baby! That's the fucking center! Let's go! That's so sick. Wow, that took so much fucking longer than I thought it would. I thought that would be, like, quick as shit. It's so crazy how, like, sometimes things go, like, maybe, like, 50 times faster than you think they will. And sometimes things go, like, 50 times slower than you think they will. How the fuck am I ever supposed to do a good job at guessing this shit? Oh god, it feels so good that we finally have it, but I just wish it hadn't take so long. But yeah, that's pretty sick. That's pretty sick. That is pretty sick. Okay. So now let's draw a box around instead of a circle in the center. So if we go to our visualizer, I think we don't have the capability of drawing a box right now, but we can add one. So I guess we're gonna take center X and center Y. And then we're going to take a width and a height. And we're going to have to look at the SVG spec or whatever before I know what else I'm going to take in here. But surely we're going to add a node called rect. And then can we just look at SVG rect? SVG rect. So he has a width and a height. And an X and a Y. So this is the X coordinate of the rect, probably the very top left. So we need to do Cx minus width over 2.0, Cy minus height over 2.0, and then here we need to add width and height. And then I want it to be, like, hollow. Can I do that? Does it have to be filled? Maybe it does. For now, instead of trying to just draw 4 lines, what I'll do instead is I'll just do alpha, reduce the alpha. So, do I need to write, like, fill on this guy or something? How do I know what color he is? Length, vertical radius, blah, 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 blah. Here. Presentation attributes, fill and stroke. Okay, so fill has 2 different meanings. Oh, I wonder what does stroke do on a rect? Ah, okay. So I just say fill none and then do a stroke on the outside. Okay. Let's just do that. Okay. Sure. So here we're going to draw a box. And we're going to take this rect width and rect height. And then we have to specify some sort of stroke. So how do we do that? Stroke may use a CSS property. I want something simpler. Just tell me how to like make it like a line. Stroke green. Stroke purple. We'll see what happens when I do that. Okay. We also want fill to be none here. So let's run again. Okay. So that's close. Definitely. I don't love that it looks like our... Oh, what the fuck is going on here? Okay. Something here is wrong. So probably our buckets are too big? What is happening here? Okay. So x negative 4.5. Okay, x 9.5. Y 8. Width 25, height 28. So what's going on there? I guess let's maybe print out all of the buckets, all of the items that we're like averaging. So here we'll say that we're printing we have like bucket, new bucket. Yep. And let's say for each of these items, let's just print out bucket rect is this. And let's just print out the rect and just see what the fuck is going on. Okay. Can we print out these things like... Oh, that's annoying. I don't like the way that this is formatted at all. Okay. But it does look like for each of these guys, their width and height within themselves is consistent, which is interesting. This feels wrong. And these 2.5s feel wrong. It feels like all of the widths are wrong, to be honest. The heights feel okay. And it feels like the widths are just fucked. So we should just be careful about where these widths are coming from. So add rect to bucket. This combined width is coming from... Oh, I'm an idiot. Because the width and height have undefined memory in them. So the width needs to be from the horizontal candidate. And the height needs to be from the vertical candidate. This is the problem with using undefined memory. You just do stupid fucking shit. Oh, hell yeah, though. Look at that. Look at that. That's slick. Yeah, that's not bad at all. Not bad at all. Okay, so that's just, you know, quick little hour and a half. Right? But I think that feels good. That feels good. Really good. Okay, so from this... Well, okay, let's do a little bit of cleanup here, actually. So now that we have this function that finds the finder patterns, this guy shouldn't be... he can do the visualizing here. Fuck it. I'll leave it the way it is. It's fine. But let's at least make sure... Let's just pull this last drawing loop of the outsides. I'm just going to pull this out because I want to make sure that what's being returned from that function is exactly the right thing. Okay, let's just do that. Just to make sure. Yeah, okay. Still looks fine. Looks fine. And then I guess just a sanity check, because sometimes you like think that you're chest testing something you're not. Let's just like make them yellow or something. Just to prove to ourselves. Yeah, okay. That's not bad at all. Not bad. Okay, so what's like the next step? I think what would be nice is if we could build an iterator that walks over these blocks and checks the timing patterns. Because now we have like a guess as to what the grid size could be, but we could be wrong. And so we should expect that each element in this thing is the width over 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 7. So we can say var elem size is equal to finder. I guess we could do something crazy here. We could say var elem width is equal to 0. We'll start him as a float. Elem height, we'll also start him as a float. And here we'll say elem width plus equals rect width. Elem height plus equals rect height. And then here say elem width divide equals finder patterns len items len. Same for height. Okay. Now, let's try to like walk one of the timer patterns. So how do we want to do that? I guess we would do something like start at the, we want like var top and bottom. I guess we want to like extract like a new rectangle. Var QR bounds. Yeah. This is going to be a rect. And we'll say that this is stud mem zeros init the rect. Is that right? 0 init rect init any type. Initializes all fields of the struct with their default value or 0 values if no default is present. Oh, so I have to do it like this. Like this. Okay. Rect is not defined. So here, I guess this is in our QR module. Struct rect. No. Const rect. Oh, I'm not supposed to. I'm supposed to pass in an initializer. Oh, I see. Yeah. Woo. I almost got that wrong. Like this. Okay. So we just need to make sure that our rect is public for now. Fix me, where should this go? I don't know. But for now, we'll just say that this is a qr.rect. And now we can, I guess we don't even want to zero initialize them, eh? We probably want to do something more like, oh, this isn't using even top, bottom, left, and right. So this isn't even the right type. Okay, we'll just do top, bottom, left, right for now. As variables in main, and I'll clean it up later, because I don't want to think about it. And so bottom, top we're going to set to F32, stud, math, max, F32 max, yep. Which I assume is not going to be like infinity. Use float max. Bottom should be 0, that's fine. Left should be float max. And right should be 0. And then we say top is equal to stud math min. Deprecated? What does he want? Use @min instead. Okay. @min, and here I take in the existing top, or rect cy minus rect height. Bottom is bottom, except plus, and this should be max now. And left cx width, and right, this should be the maximum value, and this should be plus. Okay, so I should have the bounds now. So we should be able to say QR ROI QR, well, I guess we should call this a QR CX is equal to left plus right over 2.0. Yep. And the Y is top and bottom over 2.0. And then we can try to draw a box around the whole thing. So here we say const QR width is equal to right minus left. And the height is bottom minus top. Now we can draw this thing with QR CX, QR CY, QR width, QR height. And yellow should be fine again. I just want to see something. LM width, these have to be float from int. Okay. And so this should draw a box around the whole QR code, if we did this right. I see nothing. I see nothing. Why the fuck not? Maybe because these things are too big still? I guess we will just print these things out. GDB zig out bin QR reader break on this point, run input untitled gif output test2.svg p top p bottom p left p right. Interesting. Y is top -6. Why? Why? That doesn't make any sense. Because like these boxes aren't being drawn. These yellow boxes aren't being drawn out of the bounds of the image. So what the fuck is going on? This LM width stuff is just totally wrong, but that's okay. I'm not worried about that right now. Top starts as float max, ends as this. Can I just like stood debug print top? Like this is just feels wrong by itself. So how is this progressing as we go? Top starts as this and then immediately shoots to -6. So what the fuck is rect? Oh, god damn it. Rect CY and rect height. What am I missing? Okay, so the rect height is 28. Oh, I'm an idiot. I'm an idiot, that's why. Is because this has to be divided by 2 on all of these. Fucking math, man. Math is so hard. Much better. Okay, so we've got a red box around the QR code. Hell yeah. So now from here, we should be able to find the timing patterns by moving down 7 and then right 7 elements. First of all, these have to be divided by 7. Okay, so let's print out an element width now. Debug print lm width is going to be some number, and lm height is also going to be some number. We can just print lm width and lm height. And so this should be like the size of one unit on the grid. So we have 4 by 4, which I'm pretty sure is correct. And so now let's maybe try to like draw a box around the timing areas. Or maybe we'll just around the first pixel. Let's do that. So we'll say timing row timing Y, we'll call it. Timing Y. And this is going to be 0. I guess not, we don't have to type 0 here. We can just do 7 times lm width, or height. So this is 0, 1, 2, 3, 4, 5, 6, 7. So it should be 6 times. Plus 0.5. Timing center Y. And the timing CX is the same thing, but 1 more. And then let's draw a box there. So here we're going to timing CX, timing CY, and then we'll say LM width and LM height. And what I want to see here is I want to see a red box right fucking here on the first timing element here. Fuck. That's... Oh, plus the bounds of the QR. So this is plus QR. Okay, I think what we're going to need to do is we're going to have to make conversions between the like center width height representation and the bounds version. But I'm going to do that later. For now, I think that we can just go from plus left plus top. And I think that should do it. Close. Close, close, close. So our top is 8 pixels in. Color paint, untitled GIF. GIF, 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 GIF. So if I hover here, I'm at 8.8. So let me draw something here in red. No? Pencil. Oh, that's not a pencil. That's a color dropper. Why can I never find the pencil? Oh, it's because it's just like a fucking weird shape. Okay. So I'm in 8.8. So top left of 8.8 should be the top left of the thing, which is great. And it's timing CY. I'm off by like weird amounts here, I feel like. So, oh, oops, let's do top plus here and left plus here. And then maybe we'll log the timing spots. So it should be timing CX and timing CY. Okay. Oops, wrong thing. Build and run, please. So 36.5 and 32.5. Yeah, so that's just fucked. So we're seeing 36 is 24 away from 8. Yep. Which is 6 off. So this does feel right, maybe. Okay, this is just off by 1. And then what is my left value? I don't know if I'm logging that anywhere. Maybe I will just GDB. And GDB args zig out input untitled output test2 svg. Okay. Break on this line. Run. Print left. My left is 8. Sure. Print timing cx 36.2. Print timing cy 36.5. Okay, so like theoretically the same. Now they're just super fucking off. What the fuck? Oh, because I added fucking... Let's go 6 and 6 here. Okay. So yeah, what the fuck is going on here? Let's not do this plus 0.5. Although, oh, I'm an idiot. It's plus 0.5 times the element height. Yeah, I'm just dumb. It's 6.5, 6.5, and one of these is probably 7.5. God damn it, dude. It's so hard. It's so hard. Okay, that's much better. Much better. And now the x just has to be incremented by 1. There we go. Okay, so now we have a box around a specific item, and now we want to iterate along these guys. I guess we started this at some point. So let's just see if we can go boom, 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 boom. So let's just do something like for I, while timing cx is less than some value. It's gonna be like the right edge minus minus this. Yeah. We are going to draw a box, and then we're going to increment timing cx plus equals the elem width. And this should be elem width as well. And this should be elem width as well. So now we should have a bunch of red boxes around each of the pixels here. Nice. I was off by 1. Maybe? Okay. Cool. And now I guess all we want to do when we want to like validate the timing patterns is just ensure that these are alternating color. So var expected color is going to bool expected. Var expected is starting as bright. And for each of these guys, we're just going to say if we want to like extract a color from this rectangle that we're working with. So where does this belong? We have is light pixel, and so maybe we do something like pub function is light ROI. And this is just a thing that can be done on any image. And so we'll take an ROI, which is going to be a rect. Maybe a pointer to a rect. I don't know if it matters. And for now, we're just going to const QR, so import QR. And I don't really like the idea of QR owning the rectangle, but it does for now, so we're just going to live with it. So we'll say, fix me, QR should not own rect type. That has to go somewhere else. And we're going to have to figure out, like, var left is this. Okay. Right is this. Top is this, and bottom is this, which should be abstracted. So fix me abstract. And now we want to do something like iterate for every pixel in this range. So I think maybe what makes sense is to clamp to full pixels. So we can do something like for var start y is going to be a u size equal to like top rounded up. So there's probably like seal must be, yep, seal top. And end y is going to be floor bottom. Yup. And we can do the same thing for x, and we're going to seal left and floor right. And for the ends, we have to +1 because ranges don't include those elements. No, if we floor the right side, then we're on the right edge of a pixel, which means that these range should end there. Okay, I think that's fine. So then we can say var vals equals 0 for y, start y to end y, take out y. For start x to end x, take out x. We need to pass in the image here. And do we have... let's just make a function here to be like, what is the get thing at x usize y usize? Okay, he returns a u8. This is going to be self data y times the width plus x. Great. Which means that up here we can say val plus equals image get xy. And at the end we say val divide equal by start y, the width and y minus start y, I guess this is the height, times and x minus start x. Okay. Oh, I guess we have those things already. This is, that's fine. It doesn't fucking matter. And then we just say return val is greater than 128. Okay. So now we should be able to say expected value on this time arrow is equal to the last expected value, the inversion, and then we can just check the actual things. We can say image is light ROI, and we pass in our like timing rectangle. So I guess we have const timing rect is a rect. Yep, and he has a cx of timing cx cy timing cy width of lm width and height of lm height. And then we could say image is light ROI. We take in the rect. And the image. And we can say if this is not equal to expected, stood debug panic. Unexpected timing value. I don't know. Expected 2 arguments. Okay. And seal expected type usize found F32. What the fuck? Returns the small. Oh, I have to then cast this. So int from float on all of these, I guess. Okay, let's try that. Close. This has to be a U16, I guess. It's fine. And I guess we can say val is greater than 128 times this. And this can be a use as well. Okay, so no panic there. And let's just start with expected false here. And we should panic on the first one. Yeah, we panic, unexpected time value. So that's a really good sign where there's nothing crashing, which means that we've kind of walked each of these points. And we've said, yep, that sure is what we wanted to see. Which is great. Which is great. And then we can just do the same thing with vertical. But there's no reason for me to do that now. I'll do that off stream. Okay, so that's pretty cool. We didn't get as far as I wanted to get today. I was kind of hoping that we would get to the point where I could like take this box and walk it over this whole thing, over the whole QR code. But this like ROI stuff really was a lot more complex than I originally thought. And I'm pretty stoked that we got to the right spot. So yeah, what did we do? We fixed alignment with this like 0.5 pixels off for the centers of these like finders. Found that now there isn't a perfect overlap between X and Y. So we did this like clustering thing where we said if they're close by, then we'll put them in this like bucket, and then you take the average of each bucket, we find the center. There's definitely going to be problems with that in the future, but it's good enough for now. We drew these like yellow boxes around the finders, red box around the whole image, and then red boxes around these timing patterns, and we validated that the timing patterns look good. So pretty happy with that. That sets us up pretty well for being able to take this. We now like have the grid, right? And we are set up in a like okay scenario to like take this window and slide it wherever we want. We're just gonna have to build up that abstraction a little bit. So yeah, pretty cool. Thanks for watching, guys. If you like what you saw, we're streaming most days at around 2 o'clock Pacific time. Right now it's 4 o'clock Pacific time, so anywhere between 2 hours ago and now. If you're watching on YouTube, there's a Twitch link in the YouTube description where you can swing by and say hi if you happen to be around when we're online. Right now we're working on this QR code decoder, but we've done a large variety of things. So you could check out the YouTube playlist for what's on there as well as the GitHub. If you can't see the links in Twitch, then they are just the same name on other platforms. Some things that are in there: operating systems, neural network, web dev, terminal emulator, Git GUI, diff tool, lots of stuff in there. Virtual file system. I don't know. Whatever the fuck I feel like is really what it ends up being. So yeah, I think that's all I got to plug. Thanks for watching, guys, and I hope to catch you on the next one. Bye!